In this video, you will learn how to read inputs from a GPIO pin using a push button. You should already know how to control an LED using a GPIO output pin, be familiar with if statements, and be able to use while loops. Before considering inputs, let's review how outputs work. We can set an output pin as either low or high. These are represented by the binary values 0 and 1. In the case of the Raspberry Pi, an output pin set low will output 0 volts, whereas a pin set high will output 3.3 volts. The key thing to highlight here is that we are using logic to produce a specific voltage level. In the case of inputs, the exact opposite takes place. That is, a voltage level is used to produce a logic level. It's hard to get exact electrical specifications for the GPIO pins, but after a little experimentation, I found that a voltage of about 0 to 1.2 volts produced a low input, and 1.3 to 3.3 volts produced a high input. Thus, a voltage between 1.2 volts and 1.3 volts wasn't read as either low or high. Let's see how this looks in a circuit. Here are two simple setups. Recall that pin 12 and pin 7 must be set up as input pins. Also recall that pin 6 is connected to ground and pin 1 is attached to the 3.3 volt rail. In the top example, input pin 12 will read 0 volts as a low. In the bottom example, input pin 7 will read 3.3 volts as a high. Pretty straightforward, but consider this setup. Here I've placed an open switch. That means the pin is not connected to the 3.3 volt pin, and actually it's not connected to anything. We say the pin is floating and the voltage on it could be really anything between 0 and 3.3 volts. This is a real problem as the pin will sometimes be low and will sometimes be high, and it will change by itself without us doing anything. To fix this problem, we need to make the input pin have a starting value, either starting low or starting high. We can do this using something called pull-up and pull-down resistors. On the left is a pull-down resistor, and on the right is a pull-up resistor. In both cases, we've connected to the 3.3 volt rail, a push switch, a GPIO pin set for input, and ground. The resistors will be explained in a moment. Let's first examine the pull-down resistor. Ground is at 0 volts, and with no current flowing, everywhere in this branch will be 0 volts. That means that with the switch open, the input pin will read 0 volts. If the switch is closed, current will pass from the 3.3 volt rail to ground. Only a very tiny current will ever flow into an input pin, so almost all of that 3.3 volts will be used by R1. As almost no current is flowing in R2, the voltage will remain close to 3.3 volts on both sides of R2. Thus, the GPIO pin will read a high input. This is perfect. When the switch is open, the input pin reads low, and when the switch is closed, the input pin reads high. Never do we have a floating value. For the pull-up resistor, with the switch open, we have no current and thus 3.3 volts at the input pin. When the switch is closed, 3.3 volts is used by R1, thus the voltage here is 0 volts, meaning the input pin will read a low. So this is similar to the pull-down resistor, only with high and low swapped. About the resistors, the 10 kiloohm resistors are needed to limit the current from 3.3 volts to ground. The 1 kiloohm resistors, on the other hand, are not necessary. They serve only to protect the GPIO pins in case it is mistakenly set as an output. For instance, if this input was set as an output at 0 volts, a very large current would pass from the 3.3 volt rail to the GPIO pin, likely damaging the pin. Note also that a pull-down resistor gets its name from pulling the GPIO pin initially down to 0 volts when the switch is open, and a pull-up resistor gets its name from the voltage being pulled up to high when the switch is open, in this case to 3.3 volts. You may be happy to know that you don't need to physically attach the pull-up or pull-down resistors, as you can configure the Raspberry Pi's Broadcom chip to set a pull-up or pull-down resistor internally. Let's see how that's done. As always, we make sure to import the GPIO module and set mode as gpio.board. To set up the input pin, we will use 3 arguments. The first is the pin number. Here I've chosen pin 11. Next we need to set it as an input pin. We can stop here, but if we wish to use an internal pull-up or pull-down resistor, we can define that in our third argument. Here this indicates that we want to use a pull-down resistor. For a pull-up resistor, the code would differ only slightly. I'm also going to set up an output pin. This pin will be attached to an LED and will go high whenever the input pin goes high. As my program will loop until there is a keyboard interrupt, I will use a try except block. So if the user presses Ctrl+C, the program will reset the GPIO pins and then exit. The if statement inside the loop is fairly simple. If the input is high, turn the LED on, else turn it off. Though this works fine, I can write this in a more efficient way. Here, I'm simply saying to output whatever state the input pin is at. If the pin is low, output low. If it's high, output high. Let's see this in practice. Here, pin 1 is connected to a switch, which, just to be safe, is connected to a 1 kilo ohm resistor, which is connected to input pin 11. At the top of the breadboard, pin 7 is connected to an LED, which is attached to a current limiting resistor, which is connected to ground. Notice that there are no direct connections between the button and the LED. That's because the LED is being controlled via Python code alone. Now when we press the button, the LED turns on. And there you have it, the basics on how to use an input pin.